Okay, in this chapter we're going to move beyond triangles and we're moving into polygons. Okay, so this is an important section. We'll start with 8.1. 8.1, find angle measures in polygons. So a little vocabulary. Diagonal is a segment that joins two, so this is going to be non-consecutive vertices. Okay, so that means, let's do some examples here. This would be a diagonal. This would be a diagonal. And that would be a diagonal. Okay, so two non-consecutive vertices. Remember, the vertices are the points. Okay, so those are the vertices. Okay, in this section we're going to harken back again to terminology, convex versus concave. And I'm going to throw in regular as well. So we have some more vocab here. So remember that if you had polygons that look like this, so I'm going to do two of them. Okay, so the way to tell them apart is this. If you connect vertices, so if I connect vertices, and every single time I do that, my lines stay inside, then that is a convex polygon. If I connect vertices and my line is outside, see how that's going to be outside? That is a concave. And notice it looks caved in where that V is. So concave, when you connect the vertices, you end up being outside at least one time. Okay, so that's the definition there. Regular polygons. Regular means that all sides and all angles are congruent or equal. Okay, so we're going to be dealing with mainly convex polygons, and we will sometimes deal with regular polygons and sometimes irregular polygons. Okay, moving down to the theorem piece. So here's the theorem, the first theorem we're going to talk about, and we're going to use this over and over and over again. So polygon interior angles theorem. So interior angles are these angles that are numbered 1 through 6. Those are all inside the polygon, and therefore they are interior angles. Okay, if you were to add all of them up, they have a pattern. So the sum of all the measures of the interior angles of a convex n-gon means any sided polygon that you can think of. Okay, so the sum of the measures of the interior angles of a convex polygon is n minus 2 times 180. Okay, so what does that mean? N equals the number of sides. So if you think about a triangle, we know a triangle has 3 sides. So the n would be 3. 3 minus 2 is 1, and 1 times 180 gives you 180, and that's the number of degrees that we have in that triangle. That works for any polygon. Okay, so let's talk about this. I have 1, 2, 3, 4, 5, 6 angles and 6 sides. So how many degrees are in here? So let's use that formula. So I'm going to say the number of degrees inside equals n, where n is going to be 6. 6 minus 2 times 180. So that's 4 times 180, and 4 times 180 gives us the number we need. So go ahead and let's do the math. 4 zeros, 0. 4 times 8 is 32. Pretend the 2 carry the 3, and 7. So there are 720 degrees inside this polygon. Okay, let's move on to the next page. Okay, so here's another example. Okay, the sum of the measures of the interior angles
of a what? So what shape is 360? So I'm going to have to say n minus 2 times 180 equals 360. Okay, divide both sides by 180. N minus 2 equals 2. So n equals 4. So if you have 4 sides, what is your shape called? I'm going to write it right here. So your shape is called a quadrilateral. Okay, 4-sided shape. Okay? All right, so that's interior. How about exterior? So what does exterior mean? Exterior means if you take a side and you extend it. So here's your side. Here's the extension. This is an exterior angle. You can do it with every single side. And see how you're going around in a circle? So you're going around in a circle. That's key. Because if you were to add up all of those exterior outside angles, you're going to find that you get a sum of 360 degrees. And that's why I said, think about this as going around a circle, because the circle has 360 degrees. Okay, moving on to the next slide. So here's example 1. Example 1 asks us to find the measure of the interior angles of a convex octagon. Okay, do you agree it's convex? If you connect points or diagonal, connect vertices, you're going to find that all your lines are inside. That's why it's convex. Okay, octagon. So we're going to need to remember these numbers. Octagon has 8 sides. Remember these names. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if I have 8 sides, and I want to know the number of angles that they sum to inside, the sum is always going to be n minus 2 times 180. So this is going to be 8 minus 2 times 180, which is 6 times 180, which gives me a total of 1,080 degrees. Okay, so 1,080 degrees is what the sum of the interior angles of an octagon is. Okay, example 2. No sketch this time. They say the sum of the measures of the interior, always make sure they're talking about interior and not exterior, angles of a convex polygon is 900. How many sides does this guy have? Well, n minus 2 times 180 equals 900. Divide both sides by 180. And that's going to go in there 5 times. So now you have n minus 2 equals 5. So n is going to be 7. So the answer is, if there are 900 degrees inside a convex polygon, that convex polygon is going to have 7 sides. It will be a 7-sided polygon. Okay, example 3. Find an unknown interior angle measure. Find the value of x in the diagram shown. Okay, so first off, how many degrees should I have in here? N minus 2 times 180 gives me the number I should have. So this is 4 sides, so that's 4 minus 2 times 180, which ends up being 2 times 180, which is going to equal 360. So if I have to have 360 degrees in here, can't I just do some math here and add things up? So I can say 108 plus 121 plus 59 plus x equals 360. So add up all those degrees, and you're going to get 288. So if I say 288 plus x equals 360, I'm going to find that x is going to be 72 degrees.
So I need that angle to be 72 degrees to satisfy the number of the sum of the angles inside this convex polygon. Okay, what's the value of x in the diagram shown? All right, well, what are we looking at? We're looking at not interior angles, but we're looking at exterior angles. Exterior angles will always sum to 360. Remember, it's like going around a circle. So we're going to do the same procedure we've done for example 3, only now our sum is going to be 360 because it's exterior angles. So there's no reason to use the n-2 formula. Okay, so I'm going to say x plus 2 plus 112 plus 96 plus x has to equal 360. Okay, so start adding some things together. It looks like I have 2 x's. So 2x plus, when I add up all those numbers, I am going to get, well, let's see, I'll do it and get back to you. Okay, that was 228 has to equal 360. Do some math. So 360 minus 228 gives me 132. So what's going to happen is subtract 2x equals 132, so x will equal 66. Okay, so that's how we handle that. Okay, let's go on and look at example 5. Example 5 says, find angle measure in regular polygon. Okay, so regular polygon. Number one thing to notice, that means that all the angles and all the sides are equal. The trampoline shown is shaped like a regular dodecagon. How many sides are in a dodecagon? 12. Okay, so you're going to need to have this in your vocabulary as well. So there's 12 sides in a dodecagon. Find the measure of each interior angle and the measure of each exterior angle. Oh, well, that's interesting. Well, if it's a dodecagon, I know that n-2 times 180 will give me the sum of the interior angles. Okay, so if n is 12, it's going to be 12 minus 2 times 180, which is going to be 10 times 180, which is going to be 1800. Okay, so 1800. So if I have 1800 angles as the sum of the interior, don't I know that each angle is exactly the same size? So can't I divide that by 12? If I divide it by 12, I'm finding that every single interior angle has to be 180. Okay, so every single one has to be 180. 150. How does this relate to the interior angles? We haven't talked about this, so I'm going to talk about this with a triangle because that's a little bit easier to draw than a dodecagon. So do you see how this would be an interior angle? So notice that the interior angle and the exterior angle are on a line. If they're on a line, they have to sum to 180. So if I know that the interior angle equals 150, so this is interior, then the exterior angle has to be 180 minus 150, which is going to be 30, because 30 and 150 sum to 180. And that's how the interior and the exterior angles are related. Okay, so an interior plus an exterior will always equal 180 degrees. So if you have one of them, you can get the other one. Okay, and the key with this problem was that it was a regular dodecagon. which meant that I could divide by 12 because I know that every single angle has to be the same measurement. Okay, so let's practice this on the next page of my notes. Okay, so extra practice. Find the sum of the measures of the interior angles of a convex decagon. Okay, another vocab word for you. Decagon has to be 10-sided. Okay, so they want the interior angles and they want the sum of them. So the sum equals n minus 2 times 180. Okay, so if 10 is my n, then I'm going to say 10 minus 2 times 180, and that's going to be 8 times 180, and that's going to equal 1440 degrees. Okay, so you should be doing this with your calculator as well. Okay, the sum of the measures of the interior angles, okay, so we're going to be reading carefully, on a convex polygon is 2,340. Classify the polygon by the number of sides. Okay, so I know that the sum is n minus 2 times 180, and if I already have the sum as 2340, then that's going to equal n minus 2 times 180. Okay, I always do it this way. Divide both sides by 180, and you're going to end up getting 13. So this is 13 equals n minus 2. So add the 2 to both sides, and 15 will equal n. That is a number of sides. Okay, so 15 is how many sides that convex polygon is going to equal if the sum of the interior angles are 2,340. Okay, find the value of x in the diagram shown. So you have to think about this for a second. I see I have 1, 2, 3, 4, 5 angles. It means I have 5 sides. And what is the sum of the polygon interior angles here? Well, I'm going to say n minus 2 times 180. And I had 5 for my n. 5 minus 2 times 180. So that's 3 times 180. And 3 times 180 is 540 degrees. So I have to have 540 degrees inside here. So do your math. So 100 plus 110 plus 92 plus 84 plus x has to sum to 540. So if you add all those angles up, you should be getting 386 plus x equals 540. So I'm going to get x equal to 154 when I subtract 386 from 540. Okay? So make sure you can get that. Let's go on to the bottom of this page to example, to extra practice problem 4. So what's the value of x in the diagram shown? So you have to say, wait a second, it is showing me exterior angles, and no matter what shape I have, no matter how many sides I have, the sum of those angles will always be 360. So x plus 13 plus 74 plus x plus 117 has to equal 360. Okay, add my x's up, there's 3 of them. Add my other angle measurements up, there's 204 degrees on the table so far. So subtracting away the 204 from both sides gives me 156 equals 3x, divide by 3, and I'm finding that x equals 52. Okay? Last extra practice problem here. A stop sign is shaped like a regular octagon. So if it's regular, so all angles are equal. It's an octagon, so it has 8 sides, 8 angles, all equal. Find the measure of each interior of each of the interior angles and the measure of each exterior angle. Okay, so if it's 8-sided, I can get the total number of angles, degrees inside by this formula. So 8 minus 2 times 180, and that's going to be 6 times 180, which will equal 1080. Okay, since every single angle is going to be exactly the same, I can find my interior angle by saying the sum divided by the 8 angles that are inside, and my interior angle ends up being 135 degrees. So this is interior. Okay, I remember that interior plus exterior has to equal 360, equals 180, because they're always going to be on a line. Right, so let me go back here. So this is always going to equal 180. They will always have a supplementary relationship. So if I know that my interior angle is 135, I can figure out what my exterior angle is just by doing a subtraction. Okay, so what I find is that E equals 45 degrees. So now I have my exterior angle and I have my interior angle. And I am done with this page. Okay, so now try to internalize some of this. You may want to look back at the notes and then do the homework on page 4.